Good. I'm here to make you all exceptionally hungry right before lunch, so I'm going to apologise in advance. So I'm here today to talk about image classification, which is a project I recently decided was a good idea to embark on, but not in Python. I am going to be using JavaScript for this today, staying in my happy language place, and show you how I got on. What we're going to cover is the data gathering, so how do we actually get some images that we can use to try and classify in the first place, and some of the limitations with the approach that I undertook. I'm going to cover how to gather it in Playwright, but we'll also talk about the Unsplash API as well, which is a useful tip. We're going to talk about pre-existing models with TensorFlow.js for JavaScript and which ones are actually suitable for the problem that we're trying to do today, which is find out where the cake is. I'm going to talk about how I tried to build my own model and how well or not so well that actually turned out. And then I'm going to talk about transfer learning as well, which is the idea where you take an existing model and you build your own classification head on the top. So we'll have some code, we'll have lots of images, and if you are exceptionally hungry and can't wait till lunch, you can go to the Elastic booth for brownies afterwards. How does that sound? Cool. Okay, perfect. But I should probably introduce myself. My name is CARLY RICHMOND. I am a principal developer advocate at Elastic, which is weird to say because it only got confirmed last week. I'm a front-end engineer, I'm a speaker, I'm a blogger. I will dabble in back-end services in Node.js and Java where needed, and I hang out in all sorts of places on the interweb. So if you want to say hi afterwards, if you want to connect, I'm on X, I'm on Mastodon, I am on LinkedIn as well, and I'm at carlyrichmond.com, so don't be shy. But you'll notice there's one thing that's not listed on there, is machine learning. I am not a machine learning expert at all. I did no machine learning at university. My husband did one module. I stayed as far away from it as possible. And I've been quite intimidated by the idea of doing this project, but I thought I would take, a bit of inspiration from Tom Coole's lovely talk that he did last year and do some tinkering. But I also kind of got thrown into machine learning by accident as part of my job. So Elastic does have machine learning capabilities. And as was covered in Alexander's wonderful talk on vector search yesterday, did anyone catch that talk at all? It was good, wasn't it? I'm very impressed. So I've been learning vector search for the last year. So I got kind of exposed to machine learning models. And most of the time, I would use a repository like this. I would go to Hugging Face, I would find one that suited my needs, I would generate the embeddings I need, ingest them into Elasticsearch and go on my merry way. But then I decided, you know what? I need a challenge. And I needed some help as well because you might not know this, I am a bit of a fan of baking shows. I can make a tasty cake. If you ask me to bake something that looks spectacular, you have the wrong woman. I'm really sorry. I am not great with fondant or anything like that. But I love watching baking shows, and I love watching baking shows with my 4.5-year-old son. And our favourite is It Cake? Has anyone watched Is It Cake? Yes, my people! So you know the rules then. Some of you don't, so just as a reminder, Is It Cake has 3 seasons. You can go home and binge it over the weekend on Netflix if you don't want to go out and enjoy the sunshine. And the rules are that you have a set of bakers who have to make cakes that look like real stuff. So here's an example. This is Andrew, and he made a cake that looks like a stack of plastic cups that you would find at a party. And there's a set of judges that have one pedestal in front of them has cake, and the rest of them have what's called decoys, effectively these objects, and they have to figure out which one is the cake. Now, my neighbours must think I'm a bit wacky because myself and my son get really into this. We start kind of shouting at the TV going, no, it's number 2, it's got to, but wait, that looks like fondant because it's shiny, that's got to be number 1. And we get really excited about it. But to start with, I sucked at finding the cake. I was always wrong. And I thought, I need to build something that can help me with this problem. But I didn't want to do it in Python. No offense to Python, I like Python. It was the first programming language I did at university. I have fond memories of doing Python, but you know what? It's not my happy place language. I am a front-end engineer by background. So I did some digging, and I found TensorFlow.js. So there is TensorFlow for Python, but what we're going to cover today is basically the port, which has capabilities that allow you to run it in the browser and also run it as part of a Node.js server as well. But before we get to all that, you probably realize we need data. we need images, and we need two different classifications of images because we're going to build a binary classifier. The first of which is cake. Now, I didn't want to just have regular cakes, the ones that you might see at a wedding, such as the one that we have here that is multiple tiers. The whole point of the game show is that we find cakes that look like other things. So I needed to find cakes that looked like other things. So I went and did some digging, and actually there's a set of blogs for each season that cover and introduce each baker in turn. And they will cover, you know, their name, where they're based, what kind of cakes they make, and they also normally have their Instagram. Now, I did have a look to see maybe I can use the Instagram API and pull that back, and I just gave up. I was having authentication issues, just gave up and was like, no, there's got to be a better way. So instead, I decided to use Playwright. I found that some of them had their own websites, which makes sense. And in the websites, they had gallery pages, so I could just pull out some images. So I used Playwright for JavaScript. Is everyone familiar with Playwright? I've got some nods and some shakes. Okay, cool. So for those who are not familiar, Playwright is an end-to-end testing and automation framework. It's maintained by Microsoft. It's also available for multiple languages, including Java, JavaScript, .NET, and Python. And I've been lucky enough to be playing with Playwright for probably about a year and a bit now, because I've been writing end-to-end testing and synthetic monitoring with it, and it's actually really nice. Oh, we don't need that. I need to show you the cakes and the code. So what we have here is we're using Playwright, and I have used the Firefox browser. You don't have to use the Firefox browser. There's other browsers. There's the native, there's Chromium, etc. But the point is you need a browser to instantiate the page. And then from there, I launch it. I create a page object. And the page object in Playwright, for anyone who's not familiar, is the construct that you will interact with, perform the actions, find the elements, all those other lovely things. From there, for each of the sites which I loaded, I had a static JSON file with the sites I wanted to browse. I just basically go to the page using page.goto, and then for each, I pull out all of the images using the locator. So I'm looking for the IMG elements in HTML. And then for each of them, I'm simply pulling out the source attributes. And then I join it all together. I wrote them to a file because I didn't want to keep pinging these poor people's sites repeatedly and trying to cause a distributed denial of service. That didn't seem really fair. But that's basically how we go and we find the cakes. So super simple and straightforward. But I need other things too. I don't just need cakes, otherwise we're not building a classifier to try and find cakes with a reasonable data set. And for that, I used Unsplash. Is everyone familiar with Unsplash? Yeah, most nods. So Unsplash is a massive photo repository that you can use to get royalty-free images. If you've seen some of my talks and some of the other speakers' talks, you've probably seen some Unsplash images in there somewhere. Now, they have an API, which is actually very nice. It's rate limited with the free offering, so it's 50 requests an hour. But you know what? That's fine for what we need to do. So I created an account, and I found this particular API here, which is get a random photo, which does exactly what it says in the tin. It gets you a random photo. But you can also pass in a query to say it matches a particular search term. And furthermore, you can also specify the number of photos returned. So you can get a maximum of 30 random images back from Unsplash and go on your merry way. So that's what we did here. Again, using JavaScript. Now, I didn't have to do any invoking of calls, any of the HTTP handling, because there is a JS wrapper made by the lovely people. So I just had to do an npm install of Unsplash.js. Obviously, I'd had to register for an account, so I had an API key, which I'm not showing you today, for very good reason. And then from there, I'd looked through all of the baker's galleries and found some categories that I thought might fit for extracting out. So a lot of them had reptiles, as you saw from perhaps the snake at the top from the original slide. You had candles, you had animals, purses, shoes, put those all in. And then from there, I'm just calling Unsplash to get the random set of photos. I only got 10 back for each query. Pulled out the small URL, so it returns you basically a URL object in the result, which has multiple different URLs of different sizes. So I just pulled out the smallest one, thought that's fine, that'll do for my case, and then just returned all the URLs, and that was it. I had a set of random images. So that meant that I had 367 cakes and 174 not cakes. There was a bit of, I've done too many requests in an hour, we lost some. Is this ideal? No. Think about if you're seeing some of the models that you might be using that are pre-trained, they are using thousands and thousands and thousands of images. I'm only using a few hundred, but we're going to give this a shot. We're going to see how we get on. There's other limitations too. So the first thing is not everything on the baker's sites were actually cake. Has everyone heard of the Jaffa cake case from like years ago? So for those who are not familiar, Jaffa cake is, actually just go to the supermarket and find Jaffa cakes, but there was a legal case around tax a long time ago as to whether it was a biscuit or a cake. I am not joking. Yeah, we have some weird cases here in the UK that come through sometimes. So here's an example here. There was definitely biscuits, other types of baked goods in there that I probably wouldn't have wanted. The second thing is I actually had some company logos come through. I tried my best. I made some basic assumptions about maybe they would use a search term like logo or something in the file name. No, I still ended up with some random images. So yes, that was the second problem I had. And then the third one was making the assumption that Unsplash automatically meant that something wasn't cake. I think I got lucky because I couldn't see anything that looked like cake. Now I am using my kind of skills from training over 3 seasons of watching Is It Cake with for this. But I couldn't find anything that looked remotely like that. I certainly found food that's salmon. It's definitely salmon. This burger looks suspect. I assure you it is not cake. It is a burger. I checked the classifications to make sure. But there is still some limitations with our data set. It's not a fully clean set, and that's something that, in hindsight, I probably should have scraped out and been a bit more careful with. So I didn't want to just hop straight in and build my own model from scratch. That's too scary. So I decided we'll do a pre-trained one instead. And I'm lucky that TensorFlow.js has reasonable documentation, and they have several different types of image models that you can use. The first, and I focused on these two. So image classification, where it just returns a set of class names saying, we think this image has this thing in it somewhere. It's overall this classification. And then the second one is object detection, where it will find the bounded box area of all of the elements within the image. So let's start with the object detection, not because just because it was basically the first one I covered. Has anyone heard of Cocoa SSD? No, that's good. Okay. So Cocoa SSD is the object detection model that's available with TensorFlow.js that's pre-trained. It has a funky name, and the name actually makes some sense when you know about what type of model it is, but also what dataset was used to train on it in the first place. So the SSD refers to single shot multi-box detection. So it's going to take one attempt, basically single shot when it comes to models I found is one attempt, to try and go through and find all of the boxed elements and return those when it comes to classify the image, or sorry, detect the objects within the image. It also utilizes the Cocoa dataset. It was trained on the Common Objects in Context dataset, so that's actually why it's called that. So when you actually start playing about with it in the browser, you then will get basically a box back a bit like this. So it gives you the bounding box area dimensions, and then it tells you what the classifier and the confidence level is. And that therefore means that you should have a rough idea of where the objects are in. So a lot of the kind of pet projects you find are based on tutorials like this to make a smart webcam to try and see if your dog is running about the garden or whatever it is. And obviously I was just learning, so I decided, well, I'll start with this and see how I get on. And it was actually really easy because all I needed to do to adapt their example was put an image in, not worry about the webcam feed anymore. Oops. Don't trip over that, that's not a good idea. And then from there, I had my imports. So you'll see that I'm actually importing the minified TensorFlow.js library. I've got the Cocoa SSD coming in, and then I have my own index.js where I'm doing the heavy lifting, which is all this stuff. Don't worry, I'm not expecting you to read all of that. The first thing you need to do is you need to load the model, which can take a minute. So that's why we've basically wrapped with a then. We're anticipating the promise that we'll get a model back. From there, what I did was basically had a global variable for model to pass in and assign. I then removed invisible just for some kind of tidying up to say, you know what, I don't want to show you stuff when it's loading. And then from there, I have a utility to predict the image. So all I did was pulled out the elements from the page I needed using getElementById. So super vanilla JavaScript, nothing exciting to write home about, but I pulled out my image and the container of the image. And from there, I used model.detect on the image. I didn't resize it, I just passed in the element. You're lucky that when you're running it in the browser, it does accept an HTML image element, so I don't have to translate it into a tensor or anything else funky at this point. And then for my predictions, if the predictions were over 66%, why 66%? That was the number in the tutorial. There was no rhyme or reason for it. It seemed reasonable. I created the elements here that you saw on the prior example, saying what the class is, what the bounding box is, and then added them onto the page. And that's how you get that image with the box that we saw before. Then I decided to try MobileNet. So this is an example of a classification algorithm. So it's not going to give you that bounding box back. What it is going to give you back is basically a class name and a probability. So these are quite commonly used because they're quite low power. They solve a variety of different problems. They're commonly used for classification problems and also for generating feature embeddings. So basically scanning over an image and finding the features of interest and then generating a vector associated with that feature that's been found. So MobileNet is the main one that you would use for a classification case with TensorFlow.js. So here's an example. You see, I don't have a bounding box anymore. I just have my 3 probabilities that it comes back. So for this image here, I was actually quite surprised. It doesn't seem to have picked up cake. Has anyone noticed this? We've got cup, got a picture. I don't know why it's a picture. And we've got ice cream, which I kind of understand because of the frosting on the top. But here we go. MobileNet seems to think that that's a cup. So there we go. I got into so much trouble at this point. Is everyone aware of Core's hell? Yes, I'm having some nods. People are looking at the floor and like, why are we talking about cores, Carly? Come on. It just turned into an absolute nightmare. My thought was, well, I've got this Cocoa SSD example working. Can I not just put the model in and then pull out the responses using Classify? No. It seems to be hosted in TF Hub, which is effectively Kaggle, and I ended up bouncing around. It didn't matter what I ended up doing. I just kind of gave up at this point and thought, I can't get this to run in the browser. I've spent too much time on this, and sadly I'm going to give up. I did see that there was an issue that was fixed in the prior minor version that I was using to fix a CORS problem with MobileNet, but it seems to be back, and I don't know why. So if anyone does get it working, let me know. Sorry? Headers. I tried that. I tried star headers. I tried everything. Sorry?
Keep trying.
Go get a cup of tea and run away was my response. I realized something though. I don't need the classifications in the browser for what I'm wanting to do. I just want classifications in JavaScript. So I changed my tactic. So I used the Node backend instead. I pulled in the simple MobileNet model. I load it as before. I wrote this utility to get a tensor from image, which we'll talk about why we needed that in a minute. And then I use model.classify, not detect, because this is a classification model. Or you can call predict, which seems to be constant across all the models from what I could tell anyway. And then I send my predictions back to the front end. So this was written in a Node.js backend service. And I thought, you know what? Express is doing its thing. It's fine. But the problem when I move to the backend is I don't have access to the HTML image element anymore. So what do I do? Well, we need to create a tensor. Now, a tensor is basically what all elements are accepting to relevant degrees in TensorFlow, which is why it's called TensorFlow. And what we mean by a tensor is effectively a matrix representation or a vector representation of whatever it is you've converted. That's what we're ultimately passing around between these models, because when it comes to machine learning, it's all very scary, complex maths that I don't necessarily understand. So this utility here pulls back the URL and the image from the URL, going through that list of cakes and not cakes that we had before. I convert it to an unsigned integer array using the buffer response. And then I just use this utility called decodeImage, specifying the buffer. This 3 is a magic number. It refers to the number of channels. And because this is an RGB image format, it's 3. Trust me, it's 3. And it's wrapped in this thing called tf.tidy. tf.tidy is a utility that will tidy up any tensors that you create through any of the code flow. So if I created tons of these and then was only returning one, it would tidy everything up for me. Or if I was doing all sorts of funky operations, it would tidy up the intermediary tensors, which I wouldn't need to therefore dispose of manually. The only problem with tf.tidy, which I found later, if you're doing anything funky with asynchronous, it doesn't accept asynchronous function calls. So what you need to do in that instance is dispose of them yourself using tf.dispose or dispose against the tensor itself. So then when it got to the front end, all I needed to do was get the predictions back, and then the inner HTML was set to have my class name and the prediction value in. And I therefore had my classifications, as you saw, all set. So how did I get on? This is the top 10 classifications that I got back from MobileNet as shown in Kibana. The top result is candle. I don't know if you can see that. And most of them were these kind of cakes, you know, the big wedding cakes that have the huge candles kind of dimensions. We know this isn't a candle. I can kind of understand where it's coming from with the shape, but it wasn't great at finding the cake for a lot of these. The second one that I thought was interesting was there wasn't that many, but it didn't tend to explicitly call out cake. It called out a classification known as bakery, which makes sense. It's baked goods. So okay, we'll let it away from that. But some of them are just wacky. Does anyone have a soap dispenser that looks like this in their house? Be honest. No, I thought so. The only working theory I have at the moment is it's because of this kind of funky hexagon section in there might look. Does anyone have a soap dispenser that looks like that? No? Okay, I'm out of ideas then, but it basically thinks that's a soap dispenser, so there you go. So now we have to go back to Cocoa SSD again, but you know what? We don't actually have to do that much different, so it's fine. You're still loading the model. We still need a tensor. We're running model.detect on the tensor and returning the predictions, and it still works fine. We're still doing the same prediction stuff that we had to do before, so that's all totally fine too. This is what Cocoa SSD gives us back. So can people see what the top classification is? Cake! Okay, so Cocoa SSD can tend to find it. Part of it is, I think, as well, that sometimes you have other elements within an image. So you might have two people standing next to a wedding cake, for example. And in those instances, MobileNet seemed to struggle a lot. But here with Cocoa SSD, we're getting cake back, the category we wanted, which is good. It did manage to find people a lot of the time, but it didn't always get it right. I don't know. I never thought of myself looking like a T-Rex. I kind of understand the arms and the legs, but I don't have a tail. I'm sorry. Does anyone have a tail? No? Okay. Maybe that's a bit too personal. And then sometimes it had ones that I kind of understood, similar to MobileNet, where this is a book, for example. So you can kind of understand it because it's a box with cakes in it. So okay, we'll let it off. So now the scary bit. I decided I was going to build my own custom model from scratch. This was before I learned about transfer learning. And in TensorFlow, there's basically two types of models that you have. You have sequential, which anyone from a Unix background will be familiar with pipe operators and the idea of having the output of one command being the input of the next one. That's what a sequential model is. Basically, for each stage of your layer, you're passing in to the next layer down. The second is functional, which you can pretty much within reason, as long as you don't put cycles into your model, have the layers doing far more complicated structures of inputs and outputs. So I found this blog. that talked about convolutional neural networks and thought, this is what I need to do. I'm not classifying dogs and cats. I'm classifying cake. But I should be able to figure it out, perhaps using this as a starting point. So this is what a convolutional neural network is. Has anyone heard of a convolutional neural network before? Okay, so you're the people that are going to tell me if I get this wrong. Thank you. I hadn't learned about this before, as I said. No machine learning background before, yet decided I was going to do a machine learning project. Convolutional neural network basically has what's called a series of convolution layers, as you can see. And the idea of a convolution layer, which I'll show you on the next slide, is basically it's scanning through the image at kind of matrix representation, 3 by 3, whatever you specify, and it's trying to find features within the image that are of interest. These particular things that we can use to try and eventually say, this is a zebra or a horse or whatever it is. And we always use an activation function called ReLU, which basically is eliminating negative values because it's taking the maximum of 0 and the value that you've passed it. Now, that convolution obviously gives you an output of features, which can get quite expansive. So pooling is the idea where you reduce the dimensionality to try and stop, 1, overfitting of the model, and 2, stop a dimension explosion happening. So you'll do several layers of that, convolution pooling as you go. Then it will be flattened down. You then have the classification layer, which is the neural networks that we're all used to, where it's passing through, using the features, trying to basically figure out what the classifications are. And then at the end, we use an activation function called softmax, which takes the set of values and transforms them into a set that add to 1, which is why you end up with your final classifications being it's 0.2% chance this is a horse, 0.7% chance it's a zebra, and 0.1% it's a dog. Is everyone with me that doesn't know about CNNs? I'm seeing nods. Okay. This is what I mean by the convolution layer. So you see how it's scanning all the way through and it's trying to extract the features as we go? That's what we mean by a convolutional neural network. So how to create it? Well, first I have to define it. Then I needed the training data, for which I needed images, but also labels. I needed to train it, and then I needed to classify the remaining set, and I persisted the results into Elasticsearch so I could play with them later. So how did I do that? So before I dug into this, can everyone see this code, or would anyone like it bigger? Last chance for... I see thumbs up. Thumbs up are fine. Okay, perfect. Cool. Right, so TensorFlow TF.js node, okay? We've got the same require as we had before. Notice I don't have a model in here. I have my class names, cake and not cake. We're building a binary classifier, so that's all fine. I need my tensors, but I need the tensors for every single cake or not cake image that I'm going to classify. So I wrote this little utility, which simply pulls back the image URLs matching that particular category from Elasticsearch. It's not doing anything fancy or interesting. It's a simple match query. Then I convert it into an image set. So it's just an array of tensors that I'm taking at this point. I did resize the images. I didn't do that last time, but everything else is pretty much the same. Going back, I then had to have my full set of images together. So I just joined the 2 arrays together. So you'll notice I've got a set of cakes and a set of not cakes. I then generated the labels to match and say, well, this particular one is a cake versus this one's not a cake. And then I shuffled the data set using this utility called shuffle combo. And the idea of shuffle combo is it's going to shuffle the images, but shuffle the labels and preserve the relationship between the 2. You don't want the situation where you're shuffling your data set and realize that you've changed all your labels because they're not in the right order. So it preserves that ordering for you. From there, I said everything's a tensor. So stack takes an array of tensors and converts it into a single tensor. I then had to convert my labels into a 2-dimensional tensor, which you can see because I've got these label classifiers of 1, 0 versus 0, 1. I then created the model, which we've just talked about, the idea of convolutional layers. So it's 2-dimensional convolution layer, the initial one being the image, so the width and the height and the RGB 3-channel count that we talked about before, the filters, the size of that kernel that scans through to identify the features, and then the activation function. Pooling layer, convolution layer, again, with different filtering sizes, but same activation function because we have a different dimensionality now. Pull it again, then I flattened it. Remember we saw in the diagram flattening it to a 1D. And then it goes through the classification phase. So an initial ReLU activation, and then the softmax to get the final classifications out, with the units being the class names. You then have to compile the model, specifying an optimizer. We're using the optimizer called Adam, just because I don't actually know. The loss calculation is binary because it's a binary classifier. Otherwise, you use one called categorical. And then the metrics that I'm tracking when we actually compile the model is the accuracy metric. So I'm going to get accuracy and loss back for this. Once I do that, to actually do the training step, here we go. It is here. You fit it. Model.fit, specifying the images and the labels. You have the batch size, which is the number of samples. So as you're fitting a model, it's updating a whole bunch of internal parameters as it goes when it's training the algorithm. So the batch size is the number of samples that you need to go through, images basically, before you actually update the internal parameters. The epochs is the number of times it's going through the data set. So we're going through the data set 10 times to try and classify this thing. And then we're shuffling the data again after each pass through the data. So it's not just that initial combo shuffle. Then classified all the images, output them to Elasticsearch, saved the model down, and then remember what I said about disposing of tensors and tidying up after yourself. So you can run it to dispose of the individual tensors against the tensor itself, and then tf.dispose will go through the entire array and delete all the tensors out. Does that all make sense? Cool. You'll be wondering how I got on. Well, can everyone see? Okay, maybe. This isn't great. The accuracy is not 0.48. So this is basically saying that the number of times I'm right is less than 1. That's not great. And the loss, i.e. the number of times I'm wrong, the number of mistakes that my model's making, is 8.12. And through each pass through the data, it's not getting much better. So how do you think my model did? Be honest. Yeah, I'm sorry, people. I had some issues. I had issues at the coding stage, so quite often initially I had issues with the shape. So remember I talked about the idea of tensors being effectively a vector or a matrix? That therefore means, thinking back to our high school matrix algebra, that we need to have the correct shapes. Otherwise we're going to end up getting funky errors such as this. I also had sometimes issues where the tensor had been disposed before I actually got to use it. So that was why you need to be careful, both in terms of when you're running a manual dispose, but also when you're having the situation where you're running it within tidy, because tidy might tidy up tensors and then you go to use them and they're not there anymore. So just be careful with that. But it wasn't just TensorFlow. Sometimes the issue, sadly, was between chair and keyboard. Does anyone want to handle? So this was the change to fix the issue. So this was the original code that had a problem. Does anyone want to tell me what's wrong with it? Exactly. So not cake responses, getting cakes back. So it basically was trying to classify cakes as not cake, the cake being a lie in this particular case. This is how it did. Everything is cake. I'm not proud of this. I have no idea to this day. I tried, so originally I thought it was the code, and that's why I put the fix in. And I thought, okay, maybe that's the problem. It's clearly a training issue. Okay, fine. No. Then I thought, maybe it's the classification category for the loss function. No. I don't know why everything is cake. I need to go away and figure it out. But for the moment, everything is cake. You know, people, cats, dogs, the lot, all cake. So I decided to try again and not do it from scratch. Because another problem might just be the data set. We've not got a lot of images. And remember, we talked about thousands of images are generally used to train algorithms normally. So I decided to go back to the drawing board, and I found out about this thing called transfer learning. And I found out about it because there's actually tutorials on it on TensorFlow to talk about it with images and also with audio as well. Because transfer learning is where you take an existing model, quite commonly the mobile nets we were talking about before, and you use that as the base for your model and build what's called a classification head on the top. So what you're effectively doing in really simple terms is you're building a mini tiny model, the bit at the end that does the final classification for you, and utilizing all the learning of all the really smart people who are actually machine learning experts, i.e. not me, to actually try and classify things and use the features that are generated through their model to try and give you a more informed response. So in this example, you can see here, which I pulled from Sky Engine, originally it pulls a full set of different classifications. It's car, trucks, bicycles, all the rest of it. But then finally, when you add in your new task on the top, the head, it's going to give you back that binary classification of a car or a truck. So we can use mobile nets with our own head to get cake or not cake back. Is everyone with me? Cool. How did I do that? It's all in here again. So you might be confused as to why there's no model at the top of the require. There is a reason for that. So let's go to how we get the mobile net model and explain it. I am loading it from TF Hub, that gaggle thing that was giving me Core's hell before. We're now using a function called load graph model. The reason for this is that we don't need the classification model. We need the feature vectors, the stage before it. And if you go on to Kaggle, there's a whole host of different models, a lot of which are compatible with TensorFlow, that will give you that feature vector stage, which is what you need to pass into your final model to actually get the final classification that you need. So I load graph model, specifying the option from TF Hub because it's from TF Hub. You'll see I warm up the model. I never did this before. I don't know if this would have affected the model. I really doubt it. But this is simply to try and make sure that when we go to do our final classifications, that the model has been processed already and it's not going to end up slowing down, because I did notice the first image did take a bit longer than the others. So that's our mobile net model. And then we have a simple transfer classification, which you see is just got, again, it's a sequential model, but we've just got those final two layers that we had before, the ReLU activation function and the softmax, in order to get the final classifiers. We don't need any of the convolution because that's going to happen in the mobile net model. Still compiling it, still using Adam, still specifying a loss function. So remember I said about if it's multiple classifiers, you need to use categorical. Here's an example here showing that. And then you've got the accuracy as well. So take the tensors and the images converted same as before. Take your labels same as before. Still stacking everything into a single tensor. Still running fit, but running it against my transfer model. And then running it against the tensors that come from the predict from the mobile net model. So what you're doing is you're getting those feature vectors, and then that is going to be converted into your new tensor. It's not the image itself. Are you with me? Cool. So then fit the model, classify everything, happy days. How did I get one? Well, as you probably guessed, you can see that the accuracy and the loss looks a lot better. So by epoch 2 or 3, whoops, giving the game away there, you see my accuracy has gone up to 1, and my loss is 0.04, which is a big difference from the model I had before that thought everything was cake. And you know what? It did do a lot better. So it's about 319 cakes. And then the remainder are classified as not cakes. So you'll remember back from those numbers, that's not correct. We've still not found all of our cake. But it's better than my own model. So you know what? I'm going to take that as a minor win. But I needed to figure out how good we were as humans against the models. Would you like to play Is It Cake? Would you like to play Is It Cake? Thank you. Okay, cool. Here's the game. Devox UK. So I want you to shout out as loud as you can when the image comes up, whether it's a cake or it's not a cake, okay? I will take majority vote. Right, here we go. Oh, cake or not cake? Cool. Yes, you were right. Cake. Cake. Yeah, you got this, you got this. I think it's giving you an easy run today, guys. This was not as simple for me. Cake, okay. Oh, want to have a guess? Okay. Yep. Not cake. I knew there was not cakes in there somewhere. Okay. I will explain why that one is cake in a minute. It comes back to one of the limitations we talked about before. This one? Cake. Okay. Here we go. You got one wrong. Right. That's not bad. So let's see. If I look at Cabana, here's your Devox UK here. So you got it right 90% of the time. And you classified 11 distinct images, because obviously there's a possibility that with the random images coming back from Elasticsearch, that it's not actually, you might get duplicates potentially. But you got that right. And then obviously the one that you got right was you said something was not cake that was cake. Remember I said about some of the images that were labels and things coming back from the pages when we were using Playwright before? Some of those are still in the data set. So that one is a cake because it's classified as coming back from the pages, even though it's not a cake. Are you with me? I know, it's a trick one, it's a gotcha. Right, but I'm sure you're all dying to know. I mean, you can go and play Is It Cake afterwards and see how you're doing over lunch. How did you do against me and my family, is what you're going to ask, right? After 3 seasons of careful watching of Is It Cake, I got one wrong of the 3 games we played. And it was the same issue that you guys had. It was one of those logos that got me. So I'm going to take that as a win. The original point of this project was I sucked at classifying cake, and I seem to be doing a lot better, probably because I watched too much of this show. My lovely husband, Andy, got 2 wrong, who is sitting right there. He doesn't watch as much as a cake as me. So he got 2 wrong. And he classified a similar number of images as well in terms of the duplicate, so that was all fine. How does it compare against a 4.5-year-old? You know what? We've got to give him some credit. He's 4.5. He got the cake 67% of the time. He got 23 cakes right, 23 classifications right, and 11 wrong. I think that's not too bad for a 4.5-year-old, right? So you know what? We seem to be better than the models when it comes to finding the cake. Whether it's because we spend too much time watching these shows, I don't know. It's probably likely, but there we go. So I'm going to have to admit, I'm going to have to eat a bit of humble pie here. Had to put in another baking joke, I'm sorry. I thought this was going to be a lot easier than it was. I thought that, maybe I'd get something that would find cake and not cake and not have everything be cake. It's really difficult. There's a lot of learning associated with it. I feel like I have compressed a lot of information in my head. But you know what? It was a fun project. I don't regret it. I enjoyed it. I think it would be nice to explore further stuff in JavaScript about how I can potentially do things like image search and stuff and utilize those feature vectors. So I don't feel like this was a waste of time. Am I a machine learning expert? Absolutely not. I didn't get this right at all. And I'm happy to say that I'm not. But I'm also happy to have a bit of appreciation that all the models that I have been using through the past year and a bit of my job take a lot of effort, training, and research to come together. So we should show appreciation for those people that are far smarter than me that have been building these models. So we talked about data gathering today, talked about how we use Playwright and Unsplash.js to build a data set for cake and not cake. We talked about the pre-existing models you can use in the browser or not in the browser as far as Chorus is concerned, and how you can also use them in Node.js implementations as well. We talked about my model and how bad it was and how I still can't find the not cakes, but you know what, maybe next year we'll find out. And then we talked about transfer learning as well and how that's a useful way to try and have a far more accurate solution by leveraging existing training on models that have been already done. If you would like, check out the resources. So the GitHub, which is also available in the QR code down here, has every single Stack Overflow issue I looked at as I went along the way, because there's some that I didn't include in here for time. It includes all the resources I use for learning about this. It has all of my code in it. If you want to try and get the model to improve, let me know. And it also includes resources such as the TensorFlow.js web tutorials that are available, which are really good as well. And there's also a link to Is It Cake if you want to go and play the game later. With that, it has been a pleasure, Devox. Thank you for your time. We do have time for questions, but given I've been talking about cake right before lunch, I am not going to be offended if you need to run off and find something to eat. Thank you very much.